I'm going to give you that a different version, and the different version is the orbital wave functions can be represented with sign conventions also, and what is the sign of respective orbital lobes. And then we need to understand Garrett and ungarrett also. So these are the shapes of various orbitals we discussed. So what is angular nodes? What is radial node? So how many radial nodes we have for a given orbital, and how many angular nodes are there for a given orbital, and the shape of d orbitals in between axis orbitals and along axis orbitals, and what are the nodal planes for dxy, dyz, and dzx, and dx square minus y square. So for dx square minus y square, I'm giving the nodal planes. I'm giving nodal planes for dx square minus y square. Suppose if you are taking them, so this is x-axis and y-axis of dx square minus y square. So just imagine a line, which is passing through a plane, which is passing through Q1 to Q3, Q1 to Q3, exactly if you are taking. So just imagine this. So exactly at 45 degrees angle from Q1 to Q3, exactly at 45 degrees angle plane. So over that plane, there is no possibility of electron. So similarly, here also we can write. So this is another plane. This is another plane, which is passing through Q2 to Q4. Nodal planes for dx square minus y square. One plane will be 45 degrees at 45 degrees angle passing from Q1 to Q3, we can say. And another plane is passing from Q2 to Q4 again at 45 degrees angle. This plane is called x is equal to y minus y is equal to 0, and this is called x is equal to minus y or x plus y is equal to 0 plane. So for dx square minus y square also, there are two nodal planes. There are two nodal planes except dz square. Except dz square. Remaining all are having nodal planes. So I'm giving the nodal planes here. Nodal planes here. One is x plus y is equal to 0. X minus y is equal to 0 here. One is yz and x here. Is x, y, and y here. X, y, and xz. These are the nodal planes. Right. So these are the nodal planes given the orbitals. digit square. And for digit square, just imagine there is a conical space. There is a conical space. So two conical nodes, two conical nodes are available. So for digit square, there is only two conical nodes, but no nodal planes. But for remaining all orbitals, there are nodal planes. Okay, right. So this is the idea of number of nodal planes for every d orbital, except digit square. Remaining all are having nodal planes. For f orbitals, you just need only the names of orbitals. Orbitals are enough. So fzq, fxyz, fz of x square minus y square, fx of y square minus z square, and fx cube x square. So these are the orbitals we should have. Right. So these are the orbitals shapes of f orbitals particularly. Now let us go for the sign convention what we commonly use for lobes of the p orbitals and d orbitals. I'm giving that. So there is, we are going to introduce two words called gerade and ungerade. And some people read it as gerade and ungerade. Whatever you read it, no problem. So gerade and ungerade, or gerade and ungerade. There are two kinds of orbitals we have. This is exclusively for advanced and the corner point of advanced. Mostly very, very rare question they might ask over this point, but I'm trying to cover that also. There are two kinds of orbitals. One is called gerade orbitals, and other one is called ungerade orbitals. And the left side diagram drawing, left side picture drawing for px, positive and negative, we represent the lobe signs. For py, positive and negative, and for pz, positive and negative. positive and negative. So along p x-axis, along x-axis, we should take that positive x and negative x. Yes, Mister.
So
Medanshu,
good afternoon. It's like breaking, sir. When you're talking, only
maybe
happening,
some in
sir.
the previous class also the people said I think it may be some headset issue. I asked for another headset, but it is not available. System headset is a problem. It might be
Okay, sir. Thank you, sir.
okay. There are two kinds of orbitals called gerade and ungerade. Gerade and ungerade. So use the same convention and copy this left side diagram also. Gerade means that symmetrical and ungerade means that unsymmetrical. Gerade means symmetrical and ungerade means unsymmetrical. So what is meaning of symmetrical? What is meaning of unsymmetrical? Just we will discuss that, no problem. And see carefully the left side representation. Left side representation. So for dxy, dyz, dzx, xy, dyz, dzx, representation of the lobes with sign. The lobe sign means that it is wave function sign, psi representation.